So we have this guy parachuting. So we gotta draw this dude here, put a parachute on him. I'm a really bad drawer. So here's his parachute, and the guy's holding a camera. So there it is, a rock-sized camera. Okay, is the camera starting from rest? No, because they tell us in the problem the parachutist is descending at a speed of 10 meters per second. So the guy has a downward velocity of 10 meters per second. So what's the initial velocity for the camera? Negative 10 meters per second. So why am I saying negative 10? Because it's going down. So let's put our sign convention. You know, the better you make your diagram, the more clear it'll be. So if you're having trouble with these problems, you know, are you doing a diagram? You should always start with a diagram. So down is negative, up is positive, like that. So that's why I made the initial velocity of the camera negative. So we'll say that's the camera. Okay, so the ground is down here. So what other information do we have? So the initial height of the camera is 50 meters. So that's going to be the displacement. So from there down to the ground, the displacement of the camera is what? Negative 50. So why do we have to make it negative? Because it is the camera, from the time it's released to when it hits the ground, does the camera travel down or does the camera travel up? Down. So that's why I make the displacement negative, right? Negative 50. Okay, there's one other piece of info we know that's not said in the problem. The acceleration. As the camera falls, we know the acceleration is equal to gravity. This is a free fall problem, which is why we're going to watch the free fall video today. Gravity equals negative 9.8. Okay? And then right before, so look, part B, look at part B, what is the velocity of the camera just before it hits the ground? I can't tell you how many times I've had kids say to me, isn't the velocity 0 when it hits the ground? You know, it comes down and goes, doesn't it stop? Like, well, yeah, but is that what the question's asking for? No. The question wants us to solve for right before it hits. So like when it's a nanometer above the ground, right before hitting, what is V final? So we're solving for that, and then what else? Time. So let's put T in here.
And it doesn't necessarily go to back to 0 when it hits the ground, because there's pieces flying everywhere.
Yeah, when it hits the ground, it could bounce up. Exactly. Okay, so A. So now here's where you got to have your motion equations. I'll give you the motion equations on the quiz, so you don't have to memorize them. You just have to know how to use them. Fair enough. So you got your list of motion equations, the 4 equations. Which equation could we use to solve for time for part A? We could do, well, I'm just thinking of the equations in my head. The third one, but we don't have V final. So you know what I would do, guys? Because look, here, I'm gonna write all the equations out. X equals 1/2 AT squared plus V initial T. X equals 1/2 V final plus V initial times T. V final equals V initial plus AT. And then V final squared equals V initial squared plus 2AX. You will be much better off solving for part B first. Do B, then go back and do A. Because look, what's the only equation where you could solve for time directly? The only equation you could do that with is what? This one. But what's the bummer with that one? So you got 2 T's here. You got T squared and T. So what's that going to lead you to? A quadratic. That's going to be a quadratic. You're going to have to use the quadratic equation to solve that, which you could do. I would recommend avoiding that if you can, because it's really time consuming. So look, let's do part B first. Okay. So let's do part B. What's the velocity just before it hits the ground? So which equation could we use for that? The last one. Go v final squared equals v initial squared plus 2ax, and we can solve for v final. So v final is going to be square root, and remember from math class, square roots are always plus or minus. Does that sound familiar? Square roots are always plus or minus. You got to pick which one. So we're going to go v initial squared plus 2ax. So v final is going to be plus or minus v initial is negative 10 plus 2 times negative 9.8 times negative 50. All right, so look, what happens to these negatives there? They cancel. So we get v final as 32.86. Plus or minus, which one? Minus. You have to choose the minus. Why is it minus? It's going down. So we now know that this v final, we figured out that v final is negative 32.86 meter per second. All right, so now let's go back and do part A. All right, so doing part A. Now that we know v final, it's real easy. Once we figured out v final, it's real easy. So what can we do now? Which equation? Could we use the second equation to get time? Yep. Could we use the third? Yep. Or even the first, but again, the first is going to give you the quadratic. I like the third equation. Vf equals v initial plus at. So t is going to be v final minus v initial over a, and then plug the numbers in. So v final is negative, let me go down here, negative 32.86 meter per second, minus, now watch, here's where it gets a little tricky, minus, now what was v initial? Negative 10. So look, what happens to these minuses? They cancel to become plus. And then a is negative 9.8. So we end up with t equals, so that's going to be negative 22.86 over negative 9.8. The negatives cancel. And we get 2.3 seconds. So the answer to A, 2.3 seconds. The answer to B, negative 32.86. Ember. For part B, for the velocity, what equation did you use? Oh, maybe I made a calculation error. Let's see, it's right here. So here's part B, so that's going to be 100. So let's see, 2 times 9.8 times 50 plus 100. No, because this ends up being the square root. So this right here ends up being the square root of 1080. Right? Because these negative 10 squared is 100, and then these negatives right here cancel. So this ends up being the square root of 1080, which is 32.86. Oh, yeah, you got to square the 10.